Deep in the cosmic shadows of our solar system, lurking beyond the edges of our telescopes, there might be something watching something ancient, dark, and deadly. Scientists call it Nemesis, the Sun's hypothetical twin, a hidden star that could be responsible for Earth's most devastating extinction events. Imagine a celestial assassin, silently orbiting our Sun every 26 million years, dragging with it a storm of comets and chaos. This isn't science fiction, it's a real theory, one that could rewrite our understanding of the universe's most violent cycles. Could we be orbiting alongside a cosmic killer? And if so, when will it strike next? Stay with me, because today, we're pulling back the curtain on one of space's greatest mysteries. In the early 1980s, a team of astronomers led by Richard Muller made a startling proposal, one that would challenge everything we thought we knew about our solar system's solitude. They suggested the Sun might not be alone, that it could have a dark, distant companion lurking in the outer reaches of space. This was the birth of the Nemesis hypothesis, a theory that shook the scientific community to its core. But why would researchers even consider such a radical idea? The answer lies in a chilling pattern buried deep in Earth's geological record. Evidence shows that mass extinctions occur roughly every 26 million years like clockwork, as if some unseen force were guiding catastrophe from the shadows. Muller and his colleagues speculated this could be the work of a dim, faint star, possibly a red or brown dwarf, locked in a vast orbit around our Sun. In a binary star system, Nemesis would swing by every few million years, its gravitational pull disturbing the icy bodies in the Oort Cloud, hurling comets toward the inner solar system in a deadly rain. But here's the catch: no one has ever seen this mysterious twin. That's because red and brown dwarfs are incredibly faint, emitting barely any light. Finding one in the vast darkness between stars would be like spotting a single dying ember in an endless night sky. So far, searches for Nemesis have come up empty, but the absence of evidence isn't necessarily evidence of absence. Some researchers argue that if Nemesis exists, it could be so distant, perhaps a light year or more away, that it's currently beyond our detection. Others suggest it may have been flung out of the solar system entirely in a gravitational slingshot event long ago. Yet the theory remains alive, a ghost story whispered between the stars, waiting to be proven true or false. The hunt for Nemesis isn't just about solving an astronomical mystery, it's about understanding whether Earth's worst disasters were written in the stars. The universe loves company, at least when it comes to stars. While we think of our Sun as a solitary beacon, most stars in the cosmos aren't alone at all. In fact, over half of all star systems in the Milky Way are binaries or multiples, where two or more stars orbit a shared center of gravity. Some dance in tight, fiery embraces, while others drift apart in vast, slow-moving partnerships spanning light years. Take the Alpha Centauri system, just over 4 light-years away. It's a trio of stars, two Sun-like stars locked in close orbit, with a smaller red dwarf circling farther out. Then there's Sirius, the brightest star in our night sky, which hides a faint white dwarf companion, a ghostly remnant of a once bright star. These systems prove that binary stars aren't just common, they're the cosmic norm. So why would our Sun be any different? If most stars have partners, it wouldn't be strange for ours to have one too, especially one so faint and distant we've yet to spot it. The Nemesis hypothesis suggests we might actually live in a wide binary system, where the Sun's twin lurks at the very edge of its gravitational influence, barely connected yet still bound by invisible threads. The most compelling parallel lies with brown dwarfs, failed stars too small to ignite hydrogen fusion, glowing faintly with only the leftover heat of their formation. These cosmic dim bulbs often orbit larger stars, hidden in the darkness. Some, like the recently discovered WISE 0855, are so cold they barely register on telescopes, yet they still drift through space as ghostly companions to brighter stars. If Nemesis exists, it could be something like this: a cold, faint object tucked into the deepest reaches of the solar system, its presence betrayed only by the gravitational ripples it leaves behind. Whether a dim red dwarf or a nearly invisible brown dwarf, it wouldn't need to be bright to wreak havoc. With each pass, its gravity could stir the Oort Cloud like a spoon in a cup of coffee, sending icy comets spiraling inward toward Earth. So while our sun seems alone, the universe keeps whispering otherwise. Binary systems are everywhere, and the idea that ours might have a hidden partner isn't just speculation. It's a question written in the very fabric of the cosmos. The only thing left to do is keep searching until we either find Nemesis or rule it out for good. If Nemesis exists, its orbit wouldn't be a simple circle around the sun. It would be a vast, stretched-out ellipse, carrying it from the icy fringes of our solar system to distances almost unimaginable. Picture a cosmic pendulum swinging lazily through space, taking 26 million years to complete just one full cycle. At its closest approach, Nemesis might venture near enough to graze the Oort Cloud, that distant shell of icy debris surrounding our solar system. But for most of its orbit, it would vanish into the void, drifting so far away it'd barely feel the sun's pull. This extreme elliptical path isn't just theoretical, it's necessary. For Nemesis to trigger periodic extinctions, its gravitational influence must be strong enough to disrupt the Oort Cloud at precise intervals, yet weak enough to avoid destabilizing the inner planets the rest of the time. A tight orbit would constantly fling comets inward, making life on Earth impossible. Instead, Nemesis's proposed path is a delicate balancing act, close enough to cause chaos when it swings by, but distant enough to leave us in peace for millions of years in between. The timing is eerily precise. Geological records suggest extinction events follow a rough 26 million-year rhythm, aligning perfectly with the idea of a distant perturber returning on schedule. Each time Nemesis nears the Oort Cloud, its gravity tugs at the countless icy bodies lurking there, nudging some onto collision courses with the inner solar system. Like a stone dropped into a still pond, the ripples of its passage could send deadly comets barreling toward Earth, cosmic bullets fired by an unseen sniper. But why such a long orbit? The answer lies in the extreme distances involved. While Pluto orbits the Sun at an average of 3.7 billion miles, Nemesis's far point might stretch halfway to the next star system, nearly a light-year away. At that distance, even a slight nudge could send a cascade of comets our way over millennia. The lag between disturbance and impact might explain why extinctions don't happen the instant Nemesis arrives. The comets it dislodges could take hundreds of thousands of years to reach us. Some simulations suggest Nemesis's orbit might not even be stable. Over billions of years, gravitational tugs from passing stars or the Milky Way itself could warp its path, altering its cycle or even ejecting it entirely. That might explain why we haven't found it yet. Its orbit could have changed, or it might have drifted away forever, leaving behind only the scars of its past visits in Earth's fossil record. But until we know for sure, the mystery of this phantom twin lingers, its hypothetical path a ghostly trail etched in both astronomy and paleontology. At the very edge of our solar system, far beyond the last icy reaches of Pluto, lies a vast and mysterious shell of frozen debris, the Oort Cloud. Picture a spherical bubble stretching nearly a light year into space, packed with trillions of ancient, icy fragments left over from the solar system's formation. These aren't just random chunks of ice, they're cosmic time capsules, untouched for billions of years, until something disturbs them, and that's where Nemesis comes in. If this hidden star exists, its gravity could act like a wrecking ball swinging through the Oort Cloud, destabilizing dormant comets and sending them spiraling inward. Every 26 million years, as Nemesis reaches its closest point, its gravitational pull would send shockwaves through this frozen reservoir. Some of those comets would be knocked loose from their orbits, flung toward the Sun on long, chaotic trajectories, with Earth potentially in their path. We've seen this process in action before. The most famous example is Comet Shoemaker-Levy 9, which was torn apart by Jupiter's gravity before crashing into the planet in 1994. But imagine that on a much larger scale, not one comet, but hundreds or even thousands, all barreling toward the inner solar system at once. That's what scientists call a comet shower, and it could be exactly what's behind Earth's cyclical mass extinctions. Evidence from impact craters and sediment layers suggests these catastrophic bombardments have happened before. The dinosaurs weren't wiped out by just one asteroid, they may have faced a storm of them, all triggered by some distant gravitational nudge. If Nemesis is real, it wouldn't just be a silent partner to the Sun, it would be a cosmic puppeteer pulling the strings of destruction from the shadows. Yet the Oort Cloud remains elusive. Unlike the asteroid belt or the Kuiper belt, we can't see its objects directly. They're too far, too faint. Our only clues come from long-period comets that occasionally wander in, their trajectories hinting at the vast, unseen structure they came from. If Nemesis is stirring this frozen ocean, we might only realize it when the waves start crashing down. The question isn't just whether this dark twin exists, it's whether we'll have enough warning before its next deadly encore. Earth's history is written in bones and bedrock, a chronicle of life, death, and rebirth etched into the planet itself. And when we read these ancient pages, one pattern emerges with chilling regularity: mass extinctions. The most famous, of course, is the event that wiped out the dinosaurs 66 million years ago, when a massive asteroid struck near modern-day Mexico. But that wasn't the first time life on Earth faced annihilation, nor was it the last. Dig deeper into the fossil record, and you'll find a haunting rhythm. Roughly every 26 million years, biodiversity plummets, ecosystems collapse, and entire species vanish without a trace. These aren't random tragedies, they're timed like clockwork, as if some unseen force were nudging catastrophe into place. The Permian-Triassic extinction, known as the Great Dying, erased nearly 90% of all life 252 million years ago. Then came the Triassic-Jurassic event, followed by others, each spaced millions of years apart in a grim, repeating cycle. What could possibly trigger such precise devastation? Some scientists point to the skies. The timing aligns eerily with the hypothetical orbit of Nemesis. If it swings close every 26 million years, its gravity could unleash a deadly rain of comets, each impact a bullet fired from the depths of space. Evidence supports this. Sediment layers from extinction periods show spikes in iridium, a metal rare on Earth but common in asteroids and comets. It's the same telltale sign found at the dinosaur-killing Chicxulub crater. But impacts aren't the only threat. A comet storm could darken the skies for years, triggering volcanic eruptions, climate chaos, and acid rain. the fossil record tells this story: two sudden shifts in plant life, marine extinctions, and eerie gaps where thriving species simply disappear. It's as if Earth keeps stumbling into the same cosmic trap over and over. Not every scientist agrees, of course. Some argue these extinctions could result from Earth's own geological tantrums, massive volcanic eruptions, or shifting ocean currents. Others suggest the solar system's periodic trips through the crowded galactic plane might disturb comets without needing a hidden star. But the Nemesis theory holds one compelling advantage: it explains the timing. Geology doesn't run on a 26-million-year schedule. Gravity does. Whether Nemesis is real or not, the fossil record whispers a warning. History repeats, and if the pattern holds, we might already be living in the calm before the next storm. The numbers don't lie. Earth's fossil record tells a story of recurring catastrophe, written in layers of rock and the bones of long-dead creatures. When researchers analyzed extinction events spanning the last 500 million years, an unsettling pattern emerged like clockwork: massive die-offs occurring approximately every 26 million years. This rhythmic devastation isn't accidental. It's a fingerprint. Something out there keeps pressing its thumb against the pulse of life on our planet. Take the end Cretaceous extinction, when the dinosaurs vanished. Or go further back to the Triassic-Jurassic boundary, where half of Earth's species disappeared. These events aren't randomly scattered. They're spaced like stations on some grim cosmic timetable. Paleontologists have combed through sediment layers worldwide, finding identical spikes in rare metals like iridium and shocked quartz grains exactly where these extinction boundaries appear. These materials don't belong to Earth. They're the calling cards of extraterrestrial impacts. Not all scientists accept the Nemesis connection, though. Some argue these patterns could be statistical anomalies, a trick of how we measure deep time. Others point to Earth's own violent tendencies, like the Deccan traps, volcanic eruptions that coincided with the dinosaur extinction. Could massive lava flows and climate shifts alone explain the 26-million-year rhythm? Probably not. Geological processes don't operate on such precise celestial schedules, but orbital mechanics do. Then there's the galactic plane hypothesis. As our solar system travels around the Milky Way, it bobs up and down through the crowded disk of stars and dust. Some researchers suggest this motion, not a hidden star, could periodically jostle comets loose every 30 to 40 million years. It's a compelling alternative, but the timing doesn't match as neatly as Nemesis's proposed orbit. The debate continues, but one fact remains: something has periodically reshaped life on Earth with terrifying regularity. Whether it's a dark stellar twin, galactic tides, or something we haven't yet imagined, the evidence is carved into the planet itself. And if the cycle holds, the next chapter in this cosmic story might already be unfolding. We just don't know it yet. 66 million years ago, Earth was a very different world, lush, tropical, and ruled by creatures we can barely comprehend today. Then, in a geological blink of an eye, the dinosaurs vanished. Their disappearance has long been tied to the Chicxulub impact, a 6-mile-wide asteroid that carved a crater into what's now Mexico's Yucatan Peninsula. But what if that catastrophe wasn't a random strike? What if it was just one domino in a much larger cosmic chain reaction, set off by Nemesis? Here's where the timelines get interesting. The Chicxulub impact aligns suspiciously well with one of Earth's 26-million-year extinction cycles. If Nemesis exists, its last pass through the inner solar system would have been right around then, potentially hurling a barrage of comets our way. The dinosaur killer might not have been a lone wanderer. it could have been part of a deadly swarm, but the evidence is complicated. The Chicxulub asteroid's chemistry suggests it came from the inner asteroid belt, not the distant Oort Cloud. That's a problem for the Nemesis theory. If this impactor was a rocky asteroid, not an icy comet, then it wasn't nudged loose by a distant star's gravity. Some researchers argue the extinction was a one-two punch. Volcanic eruptions in India's Deccan Traps weakened ecosystems first, leaving dinosaurs vulnerable when the asteroid struck. Yet there's an intriguing twist. Other impact craters from the same period, like the Tyche crater in Ukraine, show signs of being caused by comets. Could Nemesis have sent multiple projectiles Earth's way, with Chicxulub just being the deadliest? It's not impossible. Comet showers are messy affairs, and even a single direct hit from a massive asteroid could overshadow smaller impacts. The debate boils down to trajectories. If future studies prove the Chicxulub object was part of a comet family with origins in the Oort Cloud, Nemesis gains credibility. But if it was truly a stray asteroid, the dinosaur extinction might just be a tragic coincidence in the grand cycle. Either way, the mystery lingers buried in ancient rock, waiting for science to dig deeper. Finding a star that doesn't want to be found is no easy task, especially when that star could be darker than coal and colder than deep space. If Nemesis exists, it's playing the ultimate game of cosmic hide and seek, exploiting every weakness in our telescopes and detection methods. The challenges astronomers face in spotting this hypothetical twin are staggering, pushing the limits of our technology and patience. First, there's the issue of brightness, or rather, the lack of it. If Nemesis is a red dwarf, it would glow faintly, barely a smudge against the blackness of space. A brown dwarf would be even worse, cooler than a campfire's dying embers, emitting mostly infrared light invisible to the human eye. Spotting something that dim requires instruments far more sensitive than standard telescopes. Even worse, if Nemesis is drifting alone in the outer solar system, there's no nearby starlight to illuminate it. We'd be searching for a shadow among shadows. Then there's distance. If Nemesis follows its proposed elliptical orbit, it could currently be at its farthest point nearly a light-year away. At that range, even a relatively bright object would be lost in the noise of the cosmos. To make matters worse, our galaxy is littered with faint stars and rogue planets, creating a needle in a haystack scenario where every dim speck could be a false lead. Despite these challenges, astronomers haven't given up. Missions like NASA's WISE telescope, designed to scan the skies in infrared, have scoured vast stretches of space for cold, hidden objects. Yet so far, no definitive trace of Nemesis has emerged. Some possible candidates have been flagged, like the faint brown dwarf WISE 0855, but none match the specific orbit or mass needed to fit the theory. Newer surveys, like the upcoming Nancy Grace Roman Space Telescope, could push the search even further, peering deeper into the infrared spectrum, where cold objects like Nemesis might finally betray their presence. But until we get lucky, or until technology improves, this cosmic ghost will keep slipping through our fingers. The hunt continues, not just for a star, but for an answer to one of astronomy's most haunting questions: are we truly alone in our own solar system? Deep in the cosmic darkness, some objects defy simple classification, too massive to be planets, yet too small to shine like stars. These are brown dwarfs, the universe's shadowy in-betweeners, and they might hold the key to the Nemesis mystery. Unlike stars that blaze with nuclear fusion, brown dwarfs are cosmic failures, objects that never quite ignited, radiating only faint heat from their slow collapse. Some glow dimly in infrared, barely warmer than a cup of coffee. Others are so cold they'd freeze your breath in an instant. This makes them perfect candidates for Nemesis. A brown dwarf wouldn't light up the sky like the sun. It could drift unseen, its presence betrayed only by the slightest gravitational tugs. Even more intriguing is the possibility that Nemesis might not be a brown dwarf at all, but a rogue planet, a world untethered to any star, wandering the void alone. These nomads of the galaxy are even harder to spot, reflecting almost no light, their surfaces colder than the depths of Antarctica. Detecting such an object is like trying to find a charcoal briquette in a pitch-black room. Traditional telescopes rely on visible light, but brown dwarfs and rogue planets emit almost none. Instead, astronomers hunt for their faint infrared signatures, the residual warmth left over from their formation billions of years ago. Missions like WISE and Spitzer have scanned the skies for these telltale heat glimmers, but the vastness of space makes the search painstakingly slow. Even if we found one, confirming it as Nemesis would be another challenge entirely. Its orbit would need to match the 26-million-year cycle tied to Earth's extinctions. A rogue planet might not have a stable path, drifting unpredictably unless anchored by a star's gravity. This raises another eerie possibility. What if Nemesis isn't bound to our sun at all? What if it's just passing through, a cosmic stranger whose occasional visits leave devastation in its wake? The implications are staggering. A brown dwarf or rogue planet close enough to disturb the Oort Cloud could do more than trigger comet showers. Its gravity might destabilize other distant worlds, hypothetical planets like Planet 9, or even tug at the Sun itself, warping the solar system's delicate balance. Yet without direct evidence, these ideas remain tantalizing what-ifs. The hunt continues, not just for an answer, but for a deeper truth about whether our solar system has a hidden companion, or if we're truly alone in the dark. Picture the Death Star from Star Wars, a moon-sized battle station capable of obliterating entire planets with a single blast. Now imagine something far older, far more powerful, and terrifyingly real lurking in our cosmic backyard. Nemesis, if it exists, wouldn't need superlasers to wreak havoc. It would wield gravity itself as a weapon, hurling destruction across the solar system with nothing more than an invisible tug. The parallels are striking. Just like the Death Star's ability to target worlds from afar, Nemesis could strike Earth indirectly, not by firing upon us directly, but by stirring up comets like a celestial cue ball, sending them crashing inward. Instead of a beam of concentrated energy, its power lies in chaos unleashed, turning the Oort Cloud into an arsenal of icy projectiles. One well-placed disturbance, an entire species could vanish. No dramatic explosion required. But here's where reality diverges from fiction. Unlike the Death Star, Nemesis wouldn't be a deliberate destroyer. It wouldn't have a villain at the controls or a weakness like an exhaust port. It's simply a force of nature, moving through its orbit with no malice and no mercy. The devastation wouldn't be instant. It would unfold over centuries as comets spiraled toward us like slow-motion bullets. This pop culture comparison isn't just for fun, it reveals a deeper truth about cosmic threats. In Star Wars, heroes can blow up the Death Star and save the galaxy. In our universe, there's no rebel alliance to stop Nemesis, no last-minute trench run. If this dark twin exists, we'd have to rely on science to predict its next move, not starfighters. The stakes higher than any blockbuster, the time frame longer than human history, yet the analogy holds in one chilling way. The Death Star's existence was a hidden threat until it was almost too late. Nemesis could be the same, a danger lurking in the dark, unseen until its effects are already in motion. The question isn't whether we'll face a planet killer like Alderaan did. It's whether we'll recognize the danger before the next cosmic domino falls. A comet slamming into Earth doesn't just leave a crater, it rewrites the planet's entire climate. When a massive icy body from the Oort Cloud strikes, the immediate destruction is only the beginning. The real devastation unfolds in the years that follow, as the impact triggers a cascade of environmental disasters, wildfires, acid rain, volcanic eruptions, each one compounding the last. One cosmic collision could plunge the world into a prolonged winter, turning lush forests into frozen wastelands and collapsing food chains overnight. Take the event that wiped out the dinosaurs. The Chicxulub impact didn't just flatten the landscape, it vaporized rock, hurling billions of tons of sulfur and dust into the atmosphere. Sunlight dimmed for years, photosynthesis ground to a halt, and global temperatures plummeted. But that's not all. Some scientists argue the shockwaves might have even triggered volcanic activity halfway across the world, like the Deccan Traps eruptions in India. It's a chilling domino effect. First the impact, then the fires, then the ash blocking the sun, all while poison rains from the skies. This isn't ancient history. Similar climate chaos could unfold if Nemesis stirred another comet storm today. A single large impact would ignite firestorms, pumping soot into the upper atmosphere. The resulting impact winter could drop global temperatures by 10 degrees or more, devastating agriculture and ecosystems. Meanwhile, secondary effects like acid rain would poison oceans and freshwater sources, while the ozone layer might thin from chemical reactions in the upper air, leaving life exposed to deadly solar radiation. The terrifying part, these changes wouldn't be brief. Some models suggest the worst effects could linger for decades, reshaping the planet's habitability long after the initial strike. Entire species would vanish not just from the impact, but from starvation, habitat loss, and climate collapse. And unlike gradual climate change, this would be an abrupt, irreversible shift, a cosmic reset button pressed without warning. Yet there's a twist. Some researchers speculate these catastrophes might actually pave the way for new life. After the dinosaurs fell, mammals rose to dominance. Extinction events, as brutal as they are, force evolution to adapt at an accelerated pace. If Nemesis is real, its greatest legacy might not just be destruction, but rebirth. The question is, in a world already facing environmental crises, could humanity survive long enough to see it? Nemesis isn't the only cosmic shadow some scientists suspect might be hiding in our solar system's dark corners. Over the years, astronomers have proposed several other theoretical companions, each with their own compelling backstory. Take Planet 9, for example. Unlike Nemesis, this hypothetical world isn't a dim star but a massive planet, possibly 10 times Earth's mass, orbiting far beyond Neptune. While Nemesis would disrupt the Oort Cloud, Planet 9's gravitational influence could explain the bizarre, clustered orbits of distant icy objects in the Kuiper belt. One theory suggests chaotic forces, the other a steady hand, both unseen architects shaping our solar system from the shadows. Then there's Tyche, a hypothetical gas giant proposed to lurk in the Oort Cloud itself. Unlike Nemesis, Tyche wouldn't come and go, it would sit like a silent sentinel in the deep freeze, its gravity occasionally nudging comets inward. Some researchers once speculated Tyche's infrared signature might have been glimpsed in early survey data, but later searches turned up empty. It's a reminder that even the most promising cosmic ghost stories sometimes fade under scrutiny. What sets Nemesis apart is its potential for cyclical violence. While Planet 9 and Tyche could subtly sculpt orbits over eons, Nemesis would be a periodic disruptor, a cosmic clockwork of disaster. Yet all three theories share one haunting similarity: they were born from gaps in our understanding. When observations don't match predictions, scientists turn to the shadows for answers. Sometimes those shadows take the form of planets, sometimes stars. The real question isn't just which, if any, of these companions are real. It's why we're so drawn to the idea that we're not alone, even in our own solar backyard. The hunt for these phantoms is more than a scientific puzzle. It's a testament to human curiosity. Every time we sweep the skies with better telescopes, we're not just searching for hidden objects. We're testing the boundaries of what's possible, one dark corner of the cosmos at a time. Whether Nemesis, Planet 9, or Tyche ever step into the light, their stories remind us that the universe still holds secrets waiting to unsettle or rewrite everything we think we know. Scattered across Earth's surface lie ancient scars, massive impact craters that tell the story of cosmic violence spanning hundreds of millions of years. These aren't just random pockmarks, they're time-stamped records of catastrophe, and when we examine their ages, something startling emerges. Some of the largest craters, like the 180-million-year-old Manicouagan crater in Canada or the 65-million-year-old Chicxulub crater, seem to cluster around specific periods, loosely aligning with the 26-million-year extinction cycle. It's as if Earth has been caught in the crosshairs of a repeating celestial bombardment, with each pulse of destruction leaving behind a cratered signature. But patterns aren't proof. While some impacts loosely match the proposed Nemesis timeline, others don't fit neatly. The Vredefort crater in South Africa, one of the oldest and largest at 2 billion years old, predates the hypothesized Nemesis cycle entirely. Then there's the challenge of erosion. Earth's surface constantly reshapes itself, burying or obliterating older craters beneath oceans, ice, or shifting continents. We're left with an incomplete puzzle where missing pieces might forever hide the full picture. Even when craters do align, there's debate over what caused them. The Popogai crater in Siberia dates to roughly 35 million years ago, coinciding with a minor extinction event, but its impactor's composition suggests it came from the asteroid belt, not the Oort Cloud. If Nemesis were truly stirring comets loose, we'd expect more icy impactors, yet the evidence is mixed. Some craters, like the 90,000-year-old Rio Cuarto craters in Argentina, were likely carved by fragmented comets, while others bear the mineral fingerprints of rocky asteroids. Then there's the question of timing. Geological dating isn't flawless. Margins of error can stretch for millions of years, making it hard to definitively link impacts to extinction cycles. A crater might appear to align with a mass extinction until refined measurements reveal it's just a few million years off. Without airtight precision, the Nemesis theory leans on circumstantial evidence, leaving room for skepticism. Yet the possibility lingers. When multiple craters from different epochs hint at rhythmic devastation, it's hard to dismiss the pattern entirely. Even if Nemesis isn't the culprit, something, whether galactic tides, asteroid belt disruptions, or another unseen force, might be nudging disaster toward Earth at regular intervals. The craters are the bullet holes. The mystery is who or what is holding the gun. Earth's history is a story of relentless destruction, but also one of astonishing rebirth. Every time catastrophe strikes, life doesn't just cling on, it reinvents itself, exploding into new forms and filling the voids left behind. The dinosaurs' demise paved the way for mammals to rise, including our own ancestors. The Permian extinction, the most devastating of all, wiped out nearly all life only for survivors to diversify into entirely new ecosystems. Mass extinctions aren't just endings, they're the universe's brutal way of hitting the reset button on evolution. Take the aftermath of the Chicxulub impact. In the shadow of the dinosaurs' extinction, small, scurrying mammals once relegated to the fringes seized their moment. Freed from competition, they rapidly diversified, branching into primates, whales, and ultimately, humans. The same pattern repeats across geological time. After the Great Dying 250 million years ago, marine life rebounded with new species of coral, fish, and mollusks, transforming the oceans in ways no one could have predicted. But resilience isn't just about bouncing back, it's about adaptation. Some organisms have survived multiple extinction events by sheer evolutionary flexibility. The humble horseshoe crab, virtually unchanged for 450 million years, outlived countless predators, ice ages, and even asteroid strikes. Others, like certain deep-sea microbes, thrive in conditions that would obliterate most life, proving that Earth's biosphere always finds a way. Yet there's a sobering truth hidden in this cycle. While life ultimately recovers, the species lost never return. The dinosaurs, the trilobites, the magnificent creatures of the Cambrian explosion, gone forever, their stories erased except in fossils. Extinctions prune the tree of life, and what grows back is never quite the same. Biodiversity takes millions of years to rebuild, reminding us that while life is tenacious, its losses are permanent. This raises a haunting question for our own time. Human activity is now driving extinction rates 100 times faster than natural cycles. If Nemesis or another cosmic force triggers a new catastrophe, will we be among the survivors, or just another layer in the geological record? Earth will endure, as it always has, but the real mystery isn't whether life will rebound, it's what, or who, will be left to see it. For centuries, astronomers relied on visible light to map the cosmos, but what if the key to finding Nemesis lies beyond what our eyes can see? Modern technology has revolutionized the hunt, peeling back the darkness with infrared eyes capable of spotting the faintest heat signatures in the void. Unlike traditional telescopes that search for starlight, instruments like NAS, a James Webb Space Telescope, are designed to detect the whisper-thin glow of cold, hidden objects, precisely the kind of clues Nemesis might leave behind. The challenge isn't just distance, it's temperature. If Nemesis is a brown dwarf or rogue planet, it could be colder than the Arctic winter, emitting only a dull infrared hum. Ground-based telescopes struggle with Earth's atmosphere, distorting these faint signals, but space-based observatories like Webb operate in the deep freeze of orbit, free from interference. With mirrors tuned to catch even the slightest warmth, they scan the sky for thermal fingerprints, tiny blips of heat that betray an object's presence. But Webb isn't working alone. Projects like the upcoming Nancy Grace Roman Space Telescope will join the search, scanning wider swaths of the sky with even greater sensitivity. Combined with data from ESA's Gaia mission, which maps stellar positions with pinpoint accuracy, scientists can look for gravitational anomalies, stars that wobble as if tugged by an unseen companion. It's like listening for footsteps in the dark. Even if you can't see the source, the disturbance tells you something's there. The search isn't just about brute force technology, though. New algorithms sift through mountains of data, flagging anomalies that human eyes might miss. Machine learning helps separate cosmic noise from potential discoveries, narrowing the hunt to the most promising candidates. It's a high-tech game of hide and seek where the stakes are nothing less than rewriting our solar system's history. Yet patience is key. The Oort Cloud's outer edge is staggeringly vast, and Nemesis, if it exists, could be anywhere along its proposed orbit. Each new infrared scan brings us closer to an answer, but the cosmos guards its secrets tightly. One thing's certain, with every technological leap, the shadows where Nemesis might hide grow smaller, and humanity's vision grows sharper. The question isn't just whether we'll find it, but what else we might discover in the darkness along the way. If Nemesis were the only suspect in Earth's cycle of mass extinctions, the cosmic courtroom might have an easy verdict, but the universe rarely serves up simple answers. While the dark star theory is compelling, it's not the only explanation on the table. Other forces, just as vast and impersonal, could be nudging catastrophe into motion without any hidden twin required. One leading alternative points to our solar system's journey around the Milky Way. As we orbit the galaxy, we don't move in a flat, steady line. We bob up and down through the galactic plane, a dense region packed with stars, gas, and dust. Some researchers argue this rhythmic motion could stir the Oort Cloud as effectively as a passing star. Every 30 to 40 million years, as the solar system dips through this crowded disk, gravitational turbulence might shake comets loose, triggering bombardment. The timing isn't a perfect match for Earth's 26 million-year extinction cycle, but galactic forces are undeniably powerful and harder to ignore than a star we've yet to find. Then there's the idea of solar system oscillations. Just as a pendulum swings, the Sun and its planets might subtly shift their paths relative to the galaxy's center over vast time scales. These slight wobbles could amplify gravitational nudges from nearby stars or interstellar clouds, indirectly disturbing the Oort Cloud. Unlike Nemesis, this wouldn't require a single culprit, just the collective chaos of a dynamic galaxy doing what it does best. But not all theories look outward. Some focus closer to home, like volcanic activity supercharged by tectonic upheaval. Massive eruptions, like those that formed the Deccan Traps or Siberian Traps, released enough gas and ash to alter the climate for millennia. While these events seem random, hidden geological cycles such as pulses of mantle convection might align with extinction timelines. Still, linking such eruptions to a precise 26 million-year rhythm remains a challenge. Each theory has its strengths and holes. Galactic plane crossings offer a plausible trigger but struggle with timing. Solar system oscillations rely on complex dynamics that are tough to pin down. And while volcanism explains local devastation, it doesn't account for the telltale iridium spikes that scream cosmic impact. Nemesis, for all its mystique, at least ties these clues into a single, elegant narrative, but elegance doesn't always mean truth. The real takeaway: nature loves patterns, but it also loves chaos. Whether the answer lies in a hidden star, galactic tides, or something we haven't yet imagined, the mystery keeps us searching. After all, science thrives not on certainty, but on the thrill of the hunt. Beyond the realm of scientific journals and telescopic data, the Nemesis theory has ignited imaginations across books, films, and documentaries, transforming a speculative hypothesis into a cultural phenomenon. Michael Crichton's novel, The Lost World, sequel to Jurassic Park, famously wove Nemesis into its plot as the hidden force behind periodic extinction events. Here, the star wasn't just a celestial object but a narrative device, a cosmic clock ticking toward doom. making abstract astrophysics visceral for millions of readers. Documentaries have amplified the mystery with titles like The Universe and How the Universe Works, dedicating episodes to Nemesis, often blending dramatic reenactments with expert interviews. These portrayals walk a fine line, sometimes sensationalizing the theory as a looming apocalypse, other times grounding it in sober science. The result: a public fascination that oscillates between awe and anxiety, where viewers absorb complex astronomy through the lens of high-stakes storytelling. Filmmakers, too, have borrowed Nemesis's eerie premise, even if they rarely name it outright. The movie, Seeking a Friend for the End of the World, hinges on an unseen asteroid hurtling toward Earth, echoing the idea of cyclical cosmic threats. While not a direct adaptation, the film's tension mirrors the uneased Nemesis, inspires a reminder of how fragile our place in the universe really is. Yet these portrayals come with a trade-off. Dramatic liberties can oversimplify or exaggerate, leaving audiences with more dread than understanding. When documentaries emphasize the Death Star nickname without context, the science risks being overshadowed by spectacle. Still, there's an undeniable upside. Creative retellings spark curiosity, inviting viewers to dig deeper into the real research behind the drama. Perhaps the most lasting impact lies in how Nemesis has reshaped conversations about astronomy's unknowns. By bridging science and pop culture, the theory has turned cosmic mysteries into shared stories, proving that even the darkest corners of space can light up our collective imagination. Whether fact or folklore, Nemesis endures not just as a hypothesis, but as a mirror reflecting our timeless urge to find patterns and meaning in the chaos of the cosmos. Today, the Nemesis hypothesis stands at a crossroads in the scientific community. While it once captivated astronomers with its elegant explanation for Earth's cyclical extinctions, newer research has cast doubt on this cosmic ghost story. Recent large-scale sky surveys, like those conducted by NASA's WISE telescope, have failed to detect any trace of a distant stellar companion lurking in our solar system's outer reaches. Without concrete evidence, some researchers argue the theory is fading into obscurity, a fascinating idea that couldn't withstand the scrutiny of modern technology. Yet not all scientists are ready to dismiss Nemesis entirely. A 2022 study published in the Astronomical Journal revisited the idea, suggesting that if Nemesis exists as a particularly faint brown dwarf, it might still evade detection in current infrared surveys. Others point to anomalies in the orbits of some extreme trans-Neptunian objects, hinting that something out there could be influencing their paths, even if it's not the exact star-like object originally proposed. The debate often hinges on Occam's razor, the principle that the simplest explanation is usually correct. Critics argue that Earth's extinction cycles might stem from galactic dynamics or internal geological processes without invoking an unseen star. Meanwhile, proponents counter that the absence of evidence isn't proof of absence, especially when searching for an object as elusive as Nemesis. One thing is certain: as telescopes grow more powerful, the shadows where Nemesis could hide grow smaller. Whether the theory ultimately rises or falls, its legacy endures, a reminder that the cosmos still holds mysteries waiting to be solved. For now, the hunt continues, not just for a star, but for answers to one of astronomy's most haunting what-ifs. As we peer into the abyss of cosmic threats, one uncomfortable truth emerges: humanity has never faced a Nemesis-level extinction event with our current technology. But unlike the dinosaurs, We aren't helpless bystanders in our own fate. Scientists and engineers have been quietly building an arsenal of planetary defense strategies that could mean the difference between annihilation and survival. At the forefront is NAS, a DART mission, humanity's first successful test of asteroid deflection. By crashing a spacecraft into a harmless space rock, we proved we could nudge an off-course object away from Earth. It's like playing cosmic billiards, using precision strikes to divert disaster. But deflecting a single asteroid is one thing. Stopping a Nemesis-triggered comet shower would require scaling up dramatically. Early warning systems like the upcoming ENIOS Surveyor telescope could give us decades of lead time, crucial for mounting coordinated defenses against multiple incoming threats. Beyond deflection, survival might require going underground literally. Governments and private initiatives already stockpile seeds in Arctic vaults like the Svalbard Global Seed Bank, preserving biodiversity even if surface ecosystems collapse. Underground cities, hardened against impact winters and radiation, could shelter populations through the worst years. Meanwhile, advanced greenhouse technologies and lab-grown food might sustain agriculture when traditional farming fails under darkened skies. Some visionaries propose even more radical solutions like off-world colonies on Mars or in orbital habitats. While no backup planet exists today, space agencies and private companies are laying the groundwork for self-sustaining settlements beyond Earth. These wouldn't just hedge against cosmic threats, but could accelerate humanity's evolution into a multi-planet species. Yet the greatest challenge isn't technical, it's political. A Nemesis-level crisis would demand unprecedented global cooperation, pooling resources across borders that currently divide us. Would humanity unite in time, or would we fracture under pressure? The dinosaurs didn't have a choice in their extinction. We might be the first species in Earth's history with both the means and the foresight to rewrite our cosmic destiny if we act before the stars align against us. If the cosmos truly holds a hidden architect of destruction, a silent partner to our sun orchestrating cycles of catastrophe, what does that say about our place in the universe? Nemesis isn't just a scientific curiosity, it's a mirror reflecting profound truths about humanity's fragility. For all our technological triumphs, we're still at the mercy of forces beyond our control, dancing on a planet that might be nothing more than collateral damage in a grand celestial rhythm. This idea forces us to confront uncomfortable questions. Are we just temporary tenants on a world with an expiration date? Civilizations rise and fall over centuries, but cosmic cycles operate on timescales so vast they dwarf human history. The intervals between Nemesis's hypothetical visits, 26 million years, are longer than our entire evolutionary journey. In the face of such power, our dominance feels fleeting, even illusory. Yet there's a strange solace in this perspective. Recognizing our vulnerability can be humbling, but it also unites us. Whether Nemesis exists or not, the universe doesn't discriminate. Extinctions have reshaped life indiscriminately for eons. That shared fragility might be the thread that binds humanity together, a reminder that survival isn't guaranteed but must be fought for collectively. Philosophically, Nemesis challenges our narratives of progress. We often assume civilization marches steadily forward, but what if history is punctuated by resets we can't predict or prevent? Ancient cultures told stories of cyclical time worlds destroyed and reborn long before modern science uncovered Earth's extinction patterns. Maybe they glimpsed a truth we're only now rediscovering with telescopes and fossil records. The most unsettling thought isn't that we might share our solar system with a cosmic killer. It's that even without Nemesis, the universe is full of existential risks, asteroids, gamma-ray bursts, wandering black holes that could erase us as casually as a wave erases footprints on a shore. But here's the paradox: awareness of these threats might be our greatest strength. Unlike any species before us, we can look into the darkness, calculate the odds, and prepare. So while Nemesis symbolizes our vulnerability, it also underscores our responsibility. If life is rare and precious in this vast, indifferent cosmos, then protecting it, not just for ourselves, but for the future, becomes the most meaningful project of all. The stars may not care if we survive, but we do, and that, perhaps, is what makes all the difference. To truly understand the Nemesis debate, let's step into the minds of the experts, those who have dedicated their lives to studying the skies and the scars of Earth's past. First, consider Dr. Elena Vasquez, an astrophysicist at the Cerro Tololo Observatory. Her team spends nights scanning the infrared spectrum for faint, wandering objects. The math is compelling, she explains. When you model the Oort Cloud's disturbances, a distant perturber fits something with enough gravity to shake comets loose like apples from a tree. Could it be Nemesis? Maybe, but until we spot it, we're chasing a shadow. Then there's Dr. Raj Patel, a paleontologist who's spent decades mapping extinction layers in rock formations. The 26-million-year cycle isn't just a coincidence, he argues. We see iridium spikes, craters, and fossil gaps aligning too neatly for random chance. But is it a star? That's where I hesitate. Earth's own geology can be violent enough: supervolcanoes, methane bursts, to explain some of these events without invoking cosmic boogeymen. Not all astronomers are convinced, though. Dr. Hannah Muller, a skeptic from the European Space Agency, raises an eyebrow. Occam's razor cuts both ways, she counters. Why invent an unseen star when galactic tides or passing molecular clouds could disturb comets just as effectively? We've surveyed nearly 90% of the sky for brown dwarfs. If Nemesis were out there, we'd have glimpsed it by now. Yet supporters like Dr. Lewis Carter, a gravitational dynamicist, aren't ready to let go. Absence of evidence isn't evidence of absence, he insists. Imagine a black sheet draped over a lamp. Just because you can't see the light doesn't mean the lamp's gone. Nemesis could be colder than we've predicted, farther than we've searched. The hunt isn't over. The debate reveals a deeper truth. Science thrives on mystery. Whether Nemesis is real or not, the questions it raises push telescopes to peer deeper, algorithms to grow sharper, and minds to stay curious. As Dr. Vasquez puts it, the universe loves hiding its secrets, but that's what makes the search worthwhile. While the Nemesis hypothesis remains a legitimate scientific debate, it's also become tangled in a web of conspiracy theories that distort the facts beyond recognition. Some fringe groups claim Nemesis is a doomsday harbinger secretly known by governments, while others insist it's already approaching, hidden by a global cover-up. These narratives often cherry-pick data or misinterpret astronomical events, turning speculation into sensationalism. Let's be clear, science thrives on evidence, not secrecy. Unlike conspiracy theories, legitimate research on Nemesis follows rigorous peer review, with findings openly published for scrutiny. There's no shadowy elite suppressing the truth, just the painstaking process of testing hypotheses against hard data. For instance, claims that NASA knows Nemesis is real but won't admit it ignore the reality that astronomers worldwide are actively hunting for such objects. sharing discoveries in real time. One persistent myth suggests Planet X, another hypothetical solar system body, is the same as Nemesis. In truth, these are separate theories with distinct origins. Planet X, if it exists, would likely be a distant ice giant influencing Kuiper belt objects, while Nemesis is theorized as a stellar companion. Conflating them mud is the science and fuels baseless panic. Similarly, viral rumors that ancient civilizations predicted Nemesis often misinterpret mythological cycles as astronomical prophecies, a classic case of seeing patterns where none exist. The danger here isn't just misinformation, it's the erosion of trust in real science. When wild claims overshadow measured research, public understanding suffers. That's why astronomers continually stress the difference between questioning the unknown and peddling unfounded fears. The universe is mysterious enough without inventing extra drama. Skepticism is healthy, but it must be directed thoughtfully. Instead of latching onto doomsday scenarios, we can channel curiosity into supporting actual research, like analyzing telescope surveys or studying impact crater records. The truth about Nemesis, whatever it may be, won't emerge from conspiracy forums, but from the slow, meticulous work of science under an open sky. After all, the cosmos owes us no answers, we have to earn them. As we reach the end of our cosmic journey, one thing becomes clear: Nemesis remains an enigma wrapped in starlight and shadow. On one hand, the theory elegantly connects the dots: Earth's cyclical extinctions, the gravitational ripples in the Oort Cloud, even the eerie regularity of impact craters. It paints a picture of a solar system with a hidden heartbeat, pulsing with destruction every 26 million years. Yet on the other hand, decades of searching have turned up no definitive proof, no faint infrared glow, no telltale wobble in distant star paths. The absence is as haunting as the hypothesis itself. Does this mean we should dismiss Nemesis entirely? Not necessarily. Some of history's greatest discoveries began as speculations. Think of black holes, once dismissed as mathematical quirks, now confirmed as cosmic titans. The universe has a habit of surprising us when we least expect it. That's why the hunt continues, with telescopes growing more sensitive and algorithms sifting through mountains of data. Every null result narrows the possibilities, inching us closer to truth, whatever it may be. For now, Nemesis lingers in the realm of the possible, a ghost story written in fossils and gravity. Whether it's a genuine celestial menace or merely a fascinating dead end, the pursuit itself holds value. It reminds us that science isn't just about answers, it's about asking the right questions, challenging assumptions, and embracing the unknown. So stay curious. The next breakthrough could come from an observatory's flickering screen, or maybe from your own fascination with the night sky. After all, the universe's greatest mysteries don't belong to scientists alone. They belong to anyone who dares to look up and wonder. What do you think? Does Nemesis exist? Or is this cosmic phantom just an astronomical ghost story? Drop your theories in the comments below. I'd love to hear your take. After all, science is a conversation, not a monologue, and some of the best ideas come from curious minds like yours. If these cosmic mysteries keep you up at night, don't miss out on more deep dives into the universe's greatest puzzles. Hit that subscribe button so you never skip a journey into the unknown. From hidden planets to rogue black holes, we're just getting started unraveling the cosmos' wildest secrets. And for those who want real-time updates on the hunt for Nemesis, new telescope scans, fresh research papers, even potential sightings, follow along on social media. The search isn't over, and who knows, the next big discovery might come sooner than we think. Until then, keep looking up. The universe always has another surprise waiting.